Good day guys, welcome to this video that we're just going to explain one of the most common errors we find on ITS machines. On the old generation machines it was the EE1 error. On the new generation machines like the one I've got here today, it's a E03 error. It's an error that happens, it's a high gas pressure error. So what happens, there's actually a mechanical gas pressure switch inside the machine. And when the output temperature of the machine goes too high, the pressure in the machine, the gas pressure, becomes very high, and it gets to the maximum where the switch will then activate, and the controller will give the error message, switch the machine off, try 3 times, and after that lock out the machine with that error. It is mostly caused, well, virtually all of the time, it is related to external to the machine. It's not a machine error, it's the machine trying to protect itself against too low flow rate of water. So in other words, it's not getting rid of its energy fast enough, and then the output temperature goes past. Typically, if it's a ITS 3.6 or any of the machines using R410 gas, R407C gas, those machines, when the output temperature here goes over 60, so that's about 55, 53 in the bottom of the tank, you get to that region where the gas pressure will become too high. First things to look at, if you get an error like this, most common we see clients that set the temperature too high on the machine. So when the unit is installed with a thing called a loading valve, it's a very specific technique. So if your machine was installed in a way that's got this valve in, this thing that looks like a cross, if it's got a loading valve in, this maximum set point that you're allowed to set this machine to would be 53. Now, what happens is, it's when it's 53 in the bottom of the tank. With this technique, we're loading hot water from the top of the tank. Your top of the tank will already be 60, just over 60. The average temperature, mean temperature in the tank will be about 55. So do not think 53 is now the complete water tank. It's just in the bottom of the tank. When we say to the system, it should now stop. So in this case, the unit is at 55. That most likely will push it over the limit, and so it must not be above 53 when you got the loading valve. If the machine is installed without this, in our direct flow technique on new geysers, new type geysers, then 55 is okay. Any bit you back away from that temperature will give you more margin, and it will be less likely that the error happens. Now, once you've established that the set point temperature is correct for loading valve installation, the second thing is that you can do if there's errors coming up is if the loading valve system is working correctly. Now, the thing we see is flow restriction due to air in the system, could be dirt in the Y strainer, but all of that will result in a flow problem, too slow flow rate. So what will happen, a way to check it while the unit is running, is if the machine's been running for, I would say, at least 10 minutes, so the machine is nicely warmed up and stabilized, and the water in the tank must still be cold, in the sense of if you touch the pipe that comes here to the loading valve, the cold supply line from the tank. If you feel this pipe, it must be cold. Cold in the sense of municipal water temperature. If that is cold, you're expecting, with the loading valve working correctly, the outlet temperature, which you can see on this display, it's on the left, it's the one that says out. If you've got an older machine, you'll see the out. We expect that temperature to be around 50 degrees plus minus 2. So let's say from 48 to 52 degrees, somewhere in that region, it will stabilize. If you're seeing that temperature being 54, higher temperatures, 53, 54, 55, already when there's still cold water coming to the configuration, then you know that when you get to the top end, when you get close to 53 in the bottom of the tank, the outlet temperature here is going to be too high. and then it will give a high pressure error. So the things you can look for in that case, if it's loading like that, if it's and no one's fiddled with this valve, it should never be adjusted. They're preset when we send them out. First thing, the Y strainer. It's a little filter, inline filter, that's supposed to be in every installation, and any dirt from the tank or municipal line will be caught inside a little strainer. Whoops, sieve. So if you shut down the maintenance water ports, you can take out this, clean it out, make sure there's nothing stuck in there that will restrict the flow. Apart from that, there could be air in the system, but we recommend all our systems to be installed with an air release valve that will help to get rid of the air. Another reason we sometimes see high pressure errors on machines is if the installer did not put the tank temperature sensor into the tank thermostat pocket. Here's an example of a thermostat pocket from a geyser, and there's only one place the heat pump's tank temperature sensor should be, and that is deep inside the thermostat pocket in the hot water storage tank. This is the only place that the machine can accurately measure what the temperature of the tank is. If this sensor is taped to a pipe or stuck to the flange on the side, it will have an inaccurate reading, and what's going to happen is the machine will think the tank is colder than it is, and eventually your outlet temperature is going to get to that 60, and that really is what the gas pressure is about. Once that temperature gets to the 60, 61, the gas pressure, which is related to that temperature, will be at the max, and you will get an error on the machine. So very important that it accurately can sense the temperature in the tank. But that's an installation fault if it wasn't done like that. So just to give you an example of when the machine is actually, the loading valve is working correctly, no flow restrictions, no air trap, nothing in the Y strainer, everything is happy. Sometimes when you have multiple geysers in series, there's a lot more flow restriction that can cause a challenge. So what we have now is the machine is still warming up. It's only been going for about 2-3 minutes now. So it was cold, it's warming up at the moment. What's going to happen, it will recirculate through this loop. And as we said, we're expecting this temperature on the outlet to stabilize around the 50, as long as the water that's here is cold. So I'm going to feel here, and it's cold. If you want to perform this test on site, the tank might be warm, and so the water might be already warm. So what you would do in that case, you would open a tap, let water run, let's say for 5 minutes, for 10 minutes, while the heat pump is running. So the heat pump will kick in when it sees that decrease in temperature. And then what's going to happen is once you get this thing to be going for about 10 minutes to stabilize, you can close the tap, close all the taps, that you're sure there's no pressure differences in the system. And then what you're going to do is close the tap and just give it a minute or two to wait for it to stabilize, but always just feel the pipe coming to it. And as long as this is cold, then you can look for a valid reading there. So what we're seeing at the moment, this thing is standing at 49 now, seems to have sort of started to stabilize there. Might actually hit 50, but as I said, kind of the 48 to 52 region, I wouldn't be too concerned as long as this is cold. As soon as it warms up, then you've got a bit of an issue. You'll see it's at 50 now. I'm going to give you a little demonstration of what happens when you have a flow restriction. This specific model has got a gas pressure gauge, so we can see the gas pressure here inside this machine. By the way, just want to make a note, the ITS Super 4.5 kilowatt Super version uses a different type of gas. With that gas, the max output on the machine is around 80. We still limit the controller to 60, which is 60 in the bottom of the tank, which means we'll be loading at about 70 in the top of the tank. You'll be looking at about 65 degrees in your tank. And so that machine has got a lot a lot more tolerance. You can do higher temperature with it. I would still not recommend having a dirty, and we see that in the field. Someone's Y strainer is completely blocked. The flow rate is very low through the machine. And so the poorer machine, the efficiency goes down and your saving will go down and you put more strain on the machine. And so it's not the solution just to have the higher temperature version because you don't want to sort the water flow problems. So as you can see, we've kind of stabilized at 50. What I'm going to do is I'm going to cause a flow restriction in the system by actually closing the tap. So the poorer machine won't be able to get the flow it needs. It's going to recirculate on itself. It's going to take a bit of time. You'll hear the machine starts to strain more. You'll see the gas pressure is going to rise till it gets to the maximum. The outlet temperature is going to go. It's going to lag a little bit because the sensor on the pipe takes a bit of time just to warm up. And so by the time it clips, it might not be at 60 yet, but it will warm up to that point. So it's already at 55. You can hear the strain on the system. You can see the gas pressure is starting to go to the red zone. I heard the switch, the mechanical high pressure switch. It's now going to tell the controller there's a problem. You get your E03 error. We're just going to reset because it's the first time. It's going to allow for 3 times, and after that you'll have to power down. Please never power down your machine just to override it the whole time. You are going to shorten the lifespan of the machine by just ignoring the error and resetting it the whole time, and also the efficiency you're getting. You're not going to get the saving that you're supposed to be getting from this machine. As you can see, we're at 61 on the outlet, but we've run into a high pressure situation here because we had a rather severe flow restriction on this. For any further details on this, please, you're welcome to call our technical department and speak to the guys either in our Pretoria or Cape Town office technical department. But this is a way that you can quickly on site get a feel for if there's a flow problem or if there's other potential issue. Most of the time, as I said, it's simply someone that feels that they want to set the machine hotter, and so they take the set point past 53, which is going to cause a problem on loading valve. Just with regards to temperature, 50 degrees Celsius, if you keep your hand in that for a while, you'll get burn wounds. So what we see very often, incorrect installation is a problem that can cause water to be not piping hot. And the other thing is sometimes a geyser is completely undersized for the specific house. You have a little 150 liter tank, but you got 6-7 people in the house. But previously there was an electrical element on it, and the electrical element was turned to 70 degrees Celsius. Now, first of all, it's not good for the system. Mechanical stress, thermal, your losses, your thermal loss on the tank is becoming much worse when you do 70 degrees Celsius. And there's a chance of serious burn wounds if you don't have a tempering valve after the geyser. It can be very, very dangerous to have 70 degrees on tap. But what will happen, because the tank is so very hot, in the shower, in the bath in this house, you will use less hot water and combine it with cold water to get to a usable 42 or whatever temperature you like. And so you kind of artificially increase the volume available from the tank. But the real problem is the tank size is undersized for the number of people. SAN standard says 50 liter per person is the storage capacity needed. And so in that case, if you then put a heat pump on there, and now the set point, the mean temperature in the tank is 55, a house like that might now run out of hot water, not have enough hot water. It will not be a situation where the water is never warm enough. It will just be that they run out of hot water in that case. So the real solution there, add another tank in series so that you have the correct storage space. You don't need a bigger heat pump for that. The heat pump can still handle, most of the time, even our little 3.6 small machine will be able to handle 250s in series. You'll have enough hot water. Alternatively, you can go to the super version heat pump that can take the water to higher temperatures. Thanks for your time, and thanks for your support.